Hello, in this video I will be demoing the Cymbal MES, Manufacturing Execution System. This application was built on Google's Appsheet platform. Whenever you enter this app previewing as an admin user type, the first view that you see is an unreleased work orders view. Here is a multi-record view that shows all of the unreleased work orders that have been created but not yet released to the manufacturing line. If you would like to add new work orders, you can click the Add button in the top right. Right here, I'll go ahead and select what product we want to manufacture, as well as the quantity, and then the lot number. You can go ahead and hit Save. And right here, we can see that we have created work order 150 with the product Rhino Air. If we click into this specific work order, we can go ahead and release it to the manufacturing line. Now, we should be able to see at the released work orders at 0% completion, we have the work order that we just released, work order 150. If we click into here, we can see that it is currently at the coil build step of the manufacturing process. If we switch to a user that would be manning that coil build work center by logging into an email of a user that is assigned to that work center, then you can see that there is released work orders, and then there's coil builds work orders. These are all the work orders that are currently at the coil build step of the process. Let's go back to the work order 150. At work order 150, we can click into coil build and start the process. This start work indicates the work having started at the coil build step, as well as tracking the start time of the work order step. It also will record the end time. We'll get to that in just a moment, however. First, we want to record some downtime. With this downtime right here, we can go ahead and say the reason of why there's downtime. We'll say an electrical reset. All right. And we'll let that happen for a few moments while we record a duration for the electrical reset. You can see right here that we have created under the related downtime logs that there was a downtime during this particular step of the manufacturing line in coil build. As of right now, it has gone on and maintained a downtime of 0 minutes. We'll see that change over time. What we can do right now is we can do the AI QA check. So if we go ahead and click here, it's going to ask us to upload an image. Just for the sake of the demo, let's go ahead and go to Google and search bad weld for us to have an example of a bad weld for us to QA. Let's go ahead and screenshot this bad weld. And let's also screenshot this good weld. That way we can have a QA example that shows a weld passing and a weld failing. This feature right here is using Appsheet's Gemini feature that allows it to inspect a photo and fill in columns based off that photo. First, we're going to be submitting this good weld, expecting the QA to pass. And then we're also going to follow that up with a bad weld, expecting this one to fail. Let's go ahead and let this app sync while we wait for those photos to save, send to the Gemini servers, and return back with the reason why they have either failed or passed. So we can see that Gemini has came back with an observation analysis of those welds and has determined the one that we personally deemed as bad to have failed. Right here, a manager would be able to define if this weld failed because it was a specification failure or if it was a cosmetic failure. You could also mark if we want this to be fully rejected or just reworked. For this one, let's go ahead and say it just needs to be reworked. Also, Gemini has pointed out that not only has it failed, but it's failed due to porosity. There are visible porosities in the welds, whereas this good one over here, we can look at, and it has passed the test, the QA test, and has no defects mentioned. So now what we can do is we can go ahead and mark the end. We can now end the downtime. And we can just say the resolution was, it worked. It worked after electrical reset. Oops. I'll retype that. It worked after electrical reset. Then we'll go ahead and hit save, and we can see that there's a downtime of 3 minutes and 18 seconds that we saw previously. Now we can also go ahead and end the work time at this workstation. We'll have it signed off by the person who completed it and the ability to hit save. Now we can see that the coil build portion of the process is completed, and we can now move on to the coil expander. Let's go ahead and hit start work, and we see that we have now moved on from 0% completion to 25% completion, as well as the timeline right here has been updated. We can also see a few different metrics based off the time spent on the line. We have time in work in progress, we have cycle time, and we have time on task. Time on task will specifically calculate the duration between the start and end time and then sum all these together. It will not include time that was spent between it being created and unreleased into it being released, and will also not include the time that could potentially happen between steps of the process. Whereas cycle time right here, this does include the time in between steps, and then we have time work in progress. This is all the time, including the time that it was marked release but not started in step 1. We can also see the aggregation of all the downtimes that have happened in all of the steps. There's a few more things I would like to show you guys today, and the first thing is this analytics. This simply uses the power of all these downtimes and defects being stored in a structured database. This allows us to return advanced analytics and reporting on the downtime codes that were used, on the QA results, as well as the results over time of hopefully showing more passes compared to fails over time, showing improvement in the process. And then finally, the amount of tasks completed per week of each of the different stations. Next, we have a view called defect codes. Defect codes show all the 4 different options that you can select after a defect is found within QA. Right here, we see the number of occurrences that a QA caught a defect, and we deemed it to be one of these 4 codes. And then right here, we can see how often a downtime has occurred because of one of these codes as well. Moving on to downtime codes over here. Whenever there's downtimes, we can see the number of occurrences that these individual codes have caused a downtime. And then right here on this third column, we can see the total duration of how much downtime was caused by each of these codes as well.